Hello students, in this video we'll see an example of using the Poisson random variable. We will suppose that the number of pitches during an at-bat is Poisson, and the probability that the number of pitches is 3 is twice as likely as the probability that the number of pitches is equal to 4. We'd like to find the expected number of pitches. So here's the solution. Since n is Poisson, we know that the probability that n is equal to k is e to the negative lambda, lambda to the k, over k factorial. In this problem, we weren't given lambda, but we were given this information. We know the probability that n is equal to 3 is twice the probability that n is equal to 4. This tells us that e to the negative lambda, lambda to the third power over 3 factorial is equal to e to the negative lambda, lambda to the fourth power over 4 factorial times 2. And from this equation, we can do some cancellation. The e to the negative lambda on both sides will cancel out. The lambda cubed and the lambda to the fourth will cancel and just give me a lambda on one side of the equation. And so we see that 1 over 3 factorial must be equal to 2 lambda over 4 factorial. So lambda will be equal to 4 factorial over 3 factorial divided by 1/2. 4 factorial over 3 factorial is equal to 4, so this is 4 over half, so lambda is equal to 2. So we can update our problem. So the probability that n is equal to k is going to be e to the negative 2, 2 to the power k over k factorial. And so now we note that we can find, so let's recall a property of Poisson random variables. If n is Poisson, the expected value of n is going to be the sum, k goes from 0 to infinity, of k e to the negative lambda, lambda to the k over k factorial, which we can write as the sum, k goes from 0 to infinity, of e to the negative lambda, and then lambda to the k, and then I'll have the k will start at 0, but there'll be nothing here, so this 0 can turn into a 1. And then I'll have a k minus 1 factorial. We will pull out a e to the negative lambda, so I'll have a k from 1 to infinity of lambda, I'll put a k minus 1 here, so I'll factor out lambda as well, over k minus 1 factorial. And from the sum, I'll pull out an e to the negative lambda and a lambda. And we see that this sum over here can be rewritten as the sum, k goes from 0 to infinity, of lambda to the k over k factorial. Since I subtracted 1 over here, I had to add 1 over here, e to the negative lambda, lambda. And this expression over here, this infinite series, is exactly just e to the lambda. So I'll have e to the lambda, e to the negative lambda, lambda, and that will just give me lambda. So the expected value of a Poisson random variable is just the parameter lambda. So for us, the expected number of pitches, so the expected number of pitches that are at bat will be the parameter lambda, and we found that lambda is 2. So the expected number of pitches at an at bat will be 2 in this model. Thank you very much.